So our presentation is going to be about mathematics education through computer assisted instruction. And we're doing an evaluation of the Waterford Early Math and Science program. Okay, so what we wanted to do in the study is a couple of things. We wanted to test the efficacy of an individualized computerized program and wanted to compare it to traditional preschool and to traditional kindergarten math education. We also wanted to compare mathematical gains between preschool and kindergarten. And so based on previous results from other studies, we hypothesized that we would find significant gains for the treatment group for both ages, so for both kindergarten and for preschool. These are results from TIMSS, which is the Trends in International Mathematics and Science Study. And what they did is they did an international study comparing 18 countries. And out of 18 countries, the United States rated 11th, which is not great. And they looked at how many kids are in advanced level compared to their grade level, and they found that in the United States only 7% of the students are in advanced, in compare, for example, to Singaporean kids, where 38% of 4th graders are advanced and 44% of their 8th graders are advanced. So what does that mean? It means that in the United States we really need help in math education. So the National Council of Teachers of Mathematics came up with 5 essential components that kids need to know for mathematics, and those are true for kindergarten through 12th grade. And these are numbers and operations, measurement, geometry, data analysis or handling, and algebra. I want to talk a little bit about the Waterford Early Math and Science program. It's been developed for pre-kindergarten through 2nd grade kids, so ages 4 to 8. It's adaptive, which means that the child progresses at their own rate. We have many objectives, and each one of those objectives includes instructional and practice and song and assessment before they start and assessment after. So there are many different ways that we introduce each one of the learning objectives. And when the child, the point is to achieve mastery. So when the child achieves mastery, he goes to more advanced objectives. But then when he doesn't achieve mastery, what happens is there is remediation, and they either repeat previous objectives, go to more basic objectives, whatever needs to be done in order to make sure that the child actually masters the objectives they need to do. And it's very interactive and dynamic. The kids are very engaged most of the time. And I will get to show you some neat stuff in a minute. These are the standards that I talked about before. These are the number of times that those are included in our product. But I have to say, these are not, you can't just add them up and find out how many objectives there are, because we have objectives that teach more than one standard. Okay, so those are not exclusive. So as you can see, each one of those are mentioned many times, trying to get kids to really get it. So now to the fun part. I want to show you a song. This is a number song. I'm going to show. This is not perfect timing though. So I'm going to show 2 songs, and I'm going to show an activity. The songs are just fun, that's why we're showing it, but I just want to stress they're not the vast majority of the product. So just click on it.
0, 0. 0 is the number that's different from the others.
0 is a big round hole.
It's not like 1, I'm sure you'll discover.
0 is a big round hole.
It means no, nada, nothing at all.
0 is a big round hole.
If you had 5 bananas and you gave me 0,
0 is a big
would I be happy and call you my hero?
0 is a big round hole.
No, I'd still be hungry, 'cause 0 is none.
Yeah, man, nothing at all. 0 is a big round hole.
Okay, and the next one is patterns, and this is interactive, but since this is a video, you don't actually see the kids click. We did the clicks for them, so but the kid actually has to click on things.
There are patterns to see everywhere if you look closely enough. Patterns are sets of things you see over and over. Can you see the pattern here? Blue shirt, red shirt, blue shirt, red shirt, blue shirt, red shirt, blue shirt, red shirt. That's a pattern. Here's another pattern. 1, 2, 1, 2, 1, 2, 1, 2. Here's a pattern with missing parts. Click on the circle that will come next in the pattern. Green circle, yellow circle, red circle. Good job!
And then as you can see, the child gets feedback. If he gets it wrong, then we correct them. And the last thing we're going to show is a song from the geometry.
If I pulled a piece of paper, saw and cut out a design, when unfolded it's identical on each side of the line. When something is the same on either side that you can see, then we say that shape has symmetry. At the beach or in the city we find symmetry as well. It is seen in many buildings or an open oyster shell. If it's folded down the middle and would match up perfectly, then we know that we have symmetry. Everywhere we can see symmetry in many shapes and themes. In a snowflake or an acorn or a butterfly's 2 wings. Look carefully around you and I'm sure you will agree that the world is full of symmetry.
Okay. So, previous study that was done on the effectiveness of the Waterford early math and science was done by Powers and Price Johnson in 2007. And what they did is they looked at kindergarten kids, and they pre-tested them and post-tested them using the set 10 and the CSAT. They used a randomized sample where they took classrooms and randomly assigned them to either treatment or control group. And they found overall that the treatment group, which is the group who used the Waterford early math and science, outperformed the control. And they even looked at subgroups, and it was true for all subgroups. So it was true for boys, girls, Hispanic kids, and overall ELL students. So what we're trying to do in the current study is expand upon this research by adding preschool and see how that works, and then comparing it to kindergarten student results. So what we did is we had, in our treatment group, we had 114 preschool children and 56 kindergarten kids. They came to our community learning center here in Salt Lake City for 28 weeks, and they came twice a week, and every time they came they received 20 minutes of our early math and science program and 20 minutes of our early reading program. And in order to be included in the study, they had to have had at least 1,000 minutes of usage. So if they had less than that, which means they didn't come consistently, we excluded them from the study. Now what I wanted to say is that many of our kids in our experimental study also attended preschool, so 52% of the kids attended 2 to 3 days a week preschool, 11% attended 5 days a week, and also majority of the kindergarten age kids, like 86%, attended also kindergarten. So for our control group, we had 44 preschool kids and 41 kindergarten kids. They all attended a typical all-day preschool, and they also, if they were in kindergarten, they also attended an extended day kindergarten. And there was no use at all of a computerized math or reading program, but we chose those preschools and kindergarten by the fact that they actually had an early reading and an early math program. So it wasn't just a play type of environment. We used the Iowa Test of Basic Skills, ITBS, level 5, which is a kindergarten level, and we only gave them the math section. And we used it for both before the study as a pre-test and after the study as a post-test. It includes 29 questions. It's a group administration. So again, we talked earlier in other talks about how hard it is to do one-on-one administration. And questions on this test include numeracy, addition and subtraction, pattern completion, measurement, geometry, and shape recognition.
And then I'll take over to jump into what we actually did. So we broke the analysis into a couple of different types of analyses. The first one, the ANCOVA, well, in both cases, we always have the dependent variable as the post-test and co-varying the pre-test, so that we're taking out any of that initial variance in their skills at the beginning of the year. Initially, we just had group as the independent variable, that being the treatment group, so treatment versus control. And then after that, we ran another analysis where we included their grade level as well as the group by grade interaction, so that we could see what we were hoping for with the difference between preschool and kindergarten. Are we seeing gains in both groups, and how's that working? Results of the first analysis, just looking at group, we had a strong, significant result with our treatment group outperforming our controls. The graph does show the mean gain score, so that is showing post-test minus pre-test for that particular chart. On this next graph, well, first the results. So the next analysis, like I said, we included grade and the interaction term. Again, we had the strong group result. However, we did not have a significant result for grade, which means that our kindergartners were not necessarily performing better than our preschoolers when the pre-test was accounted for. And this is coming out a little bit in this interaction term that is not significant, but is getting pretty darn close with a p at 0.098. And you can see this in the charts, why I've broken it down into pre-test and post-test. So first, you'll see our preschoolers are in fact at a lower level than our kindergartners at the start of the year. And they're fairly similar, and there's a little bit of a gap, but it's not too much of a gap. When you get into the post-test, it's much more varied, and you see much bigger jumps from both preschool groups than you do from our kindergarten groups, in particular from that kindergarten control group. And that's why we lost, and we don't have a significant grade effect, because if you look at the interaction, graphing the marginal means for the post-test, so these are the post-test means having already taken out the variance from pre-test, what happens is you end up with this flat line from preschool to kindergarten. So again, these are marginal means. This doesn't mean that our kindergartners are not making any gains whatsoever, but our preschoolers are outperforming them in terms of gains to such an extent that we have that flat line. In comparison, our treatment group is showing a the line that we would expect. So our preschool group is doing better than our preschool treatment is doing better than controls, and our kindergarten treatment are doing better than controls, and it is going up. Kindergartners are performing better on the ITBS than preschoolers. Now, we found this really concerning, immediately thought, okay, there's something wrong with our control group. So we had two different cohorts as part of that control group. So we went back and actually split up the group to see if it just was the problem with one of our groups that was driving the interaction. And in fact, we got the same effect even when we split it. So it didn't matter. It was actually 2 different years that we had the control data from, and it didn't matter which year it was. We still had this same flat effect. So one thing that we don't have is additional preschools to go to, but at least from these 2 preschool/kindergartens that were included, we get the same effect in 2 different years from our control group. when you actually break it down and look at comparing just the preschool group or just the kindergarten group, that gain, so the gain for our preschool treatment group compared to the control group was not significant. It is only an effect size of 0.28, and it was a trend. It was, the F value was 3.5, so it was small, but it's still, there's still change. Our kindergartners have the nice big effect, P is less than 0.01, and the effect size is moderate at 0.56. I also wanted to point out that because the students were receiving the early reading program, we did also test them on reading. This was not the focus of the study, but we have the results, and it's a good comparison here. So the kids were tested on, again, the kindergarten level, DIBELS. That's the dynamic indicators of basic early literacy skills. And we did the same kind of ANCOVA that we did with the ITBS. And we got the results that we expected in the first place, where we have the significant group result, so the treatment group is performing better than the control group, and we have a significant grade effect. Kindergartners are performing better than preschoolers, and we don't have that interaction. So this is showing us that this same group of kids are performing the way we expect them to on reading, but it wasn't happening on math. So for some reason, within that kindergarten year, those control kids aren't making the kinds of gains that we might expect them to, not the kinds of gains that they're making, at least in preschool. In the same schools. Preschool and kindergarten is the same place.
So because reading is more verbally loaded than math, you wouldn't expect to see achievement gains in math in kindergarten the same as reading anyway. So
well, but not comparing math to reading.
No, but you're saying, just looking back at your control groups and kindergartners in general, kindergartners in math do not grow as fast as kindergartners in reading.
Right,
so there's a huge difference between those groups.
Right, but I guess, but my concern was that our preschoolers did make larger growth and our kindergartners did not within math. So it's not comparing math to reading, it's the preschool to kindergarten concern.
What did you use to measure the pre-K growth?
Same thing, the ITBS, and they were not at the floor of the, we were concerned about floors, but on the ITBS they weren't at chance value, they weren't at the floor.
Yeah, level 5 of the ITBS really shouldn't be used with pre-K.
Well,
I know because I work for the company that publishes it. So.
Okay, well it is a kindergarten test, and that's why we acknowledge that.
It
is a kindergarten test.
But the kids did better on the preschoolers they did on the
well, their actual post-test was still lower than the kindergartners, they just made more gains on it. Right. So in summary, there is a significant treatment effect for kindergarten. We had that small treatment effect that was not actually significant for preschool, and then we had this strange group by grade interaction. So the weaker effect in preschool could be due to a couple of things that we've thought about. One is that both the early math and science and the ITBS is designed for older kids. However, like I said, in the case of the ITBS, we know there wasn't a floor effect, they weren't a chance, they had a normal distribution. And the Waterford Early Math and Science, although it was initially designed for older kids, has been used now for several years with preschoolers as we're testing this out, and we're finding that it's working pretty well with them. However, this may be an indication that they need more time on the product. 1,000 minutes is where we cut it off. That is the absolute minimum at which we've been able to see changes between groups when using ERP. The EMS studies are still fairly new, and so this may be an indication that preschoolers in particular need more time on the product to actually show the kinds of growth that we might hope that they would have. And so as part of the future directions is how much time is necessary to reach that larger effect. We also need to explore what actually happened with kindergarten. Why is there so little kindergarten growth in this particular case compared to the preschoolers? It'd also be nice to do this on a larger scale so that we can do a fully nested design instead of just this smaller group comparison. And so I just want to say thank you and leave you with a picture of a little girl from our community center. Any questions? Yes?
What's the socioeconomic makeup of this group, and how big was the group?
How big? Well, we had the sizes back here.
It wasn't very big. So our control group was about 40. I have the right number. About 40 in the control group, and then in the treatment group we had way more preschoolers and kindergarten. We had 114 preschoolers and 56 kindergartens.
In terms of SES, these are generally a little more higher. This is not a low income group. We have a mix. I don't have the data for exactly. I apologize that we don't have the SES data up there, but the groups were similar in terms of their socioeconomic status, but they are a little bit higher. I mean, it's not a low income group.
Okay. Regardless of the group, you definitely, the intervention showed a growth.
Yeah.
Yes.
You know, what people don't realize, staying flat on a norm reference test is growth over
Right.
time, because you have to
Exactly.
maintain the standing within the population.
Sure.
And so it's based, the raw score is based on the age of the child as they grow.
Right.
Staying at the 50th percentile is growth. It's hard to
Right.
explain to people, but it's
These
true.
were raw
Exactly.
scores that
And
we were
so
putting
you're,
up,
even
though,
your
not their
control group
standards.
grew.
Yeah.
But what you would
Which we
expect for a
expect.
normal 5-year-old, your other group grew significantly more
Right. Right.
based on the intervention.
Exactly, and that's just the difference between preschool and kindergarten is what we don't understand.
Yeah, there's a construct and a developmental thing going on there. I can,
Yeah.
if you want to talk about it, I
Oh,
can tell you
sure.
about it.
Great.
We'll talk
Yeah,
about it later.
absolutely.
Thank you. Go ahead. Yes.
Can you report the effect sizes, adjusted and unadjusted?
I don't have that information. Sorry. The effect sizes that were calculated here were, now I have to think about how I calculated them a while ago. They were unadjusted effect sizes.
And what were they?
Well, I have
Did you show them?
the two.
Yes, the one was 0.28, I think, and the other 0.56.
I don't have the effect sizes on the others. I have the effect sizes
Okay,
here.
Okay.
Sorry,
I missed seeing them.
yeah. I don't have it on the others. I have them back at
The
work.
control group, you described it as receiving no computerized instruction in math and science.
Correct.
What type of instruction in math and science did they receive?
There, from the descriptions that we got, at least I know from one of the preschools, you'd know better about the other one.
Yes.
That they had an integrated. They didn't have a particular curriculum that I knew they were following, but the part of their daily lessons were to include lessons on math, and so they always had a lot of numeracy in particular. They did geometry exercises, and you can speak to the other one because you know that one much better.
Same thing. They had numeracy, they had a little bit of addition, subtraction, so they are doing math. They have a curriculum that the teachers are following for math instruction.
I'm sorry if you had said this, but so the children came to your son, to Waterford, okay, and was there an adult that was sort of monitoring
Yes.
as
Yes.
they played? Or?
Always.
We have a community center teacher who greets them and sets them up on the computer, goes around if there are any problems, but she did not teach them additional math concepts in addition for this specific study.
There are 15 to 20 kids on the computer at a time.
At a time.
Mhm.
And what kind of, and you had to get their parents or families to bring them.
Yes.
What kind of incentive did you give them to get them to participate?
The big incentive was always selling the product, really, in terms of, look, your kids are really going to learn from this. That's, I know, the way that Marge, our teacher, has sold it to the teachers. Word of mouth has been the best selling point for her over the years. They also get, if they have good attendance, they get books at the end of the year. What else has she given them? DVDs, CDs, all from the Waterford line. So they do have incentives for a good attendance and so reaching that 1,000 point.
But they don't
number.
receive any compensation per
Yeah,
se.
okay.
It's
No,
and
yeah.
the first year we really had to recruit. After that, it's been word of
Right.
mouth, and we have waiting lists to attend.
But the children, they were really not randomly assigned. though.
No, that's
it's
why-
by
no.
choice. Yes, no,
It
it's
was-
not a
No.
Existing
Yes.
versus people who have the resources to
come
try
in.
their children.
Yes.
or-
Absolutely.
Yes.
Unfortunately. Yeah.
And it's free.
Yes.
It's free.
You said that they did the math and science and also the reading for 20 minutes each?
Yes.
Did they do those back to back,
They-
2 times a week?
It is.
It was randomized which one they started with, but they were always back to back.
Okay, so they spent 40 minutes twice
On
a
the
week.
computer, yeah.
Okay.
And, sir, or we need to stop?
I was going to ask a similar question about 20-minute session for preschoolers.
It's actually
It's
40.
40
it's 20
minutes.
and 20.
And they do well.
Wow, that's
They do
long.
really well. We had
Yeah.
other studies that were even longer.
Yeah. All right, thank you.